Hello everyone, I hope you all are doing great. So today we'll be delving into magnetic flux, one of the most important topic in magnetic fields. Well, to understand magnetic flux, first you need to consider magnetic field. Now I have taken this figure since you are pretty much familiar to what magnet is. That's why I have taken this magnet. But either to create magnetic field, you can either use a wire, either you can use an electric magnet, anything. But for now, what you need to actually focus upon is this area. Okay, let me create a proper line. Now all the area within this black line is magnetic field. Now what if I say that what is the number of lines that are passing by this specific square? Now you all know that how the north and south pole are connected with each other. The lines are moving at this direction, and in between I have taken a specific square, and I'm asking from you that tell me how many numbers of lines are passing by this specific square. So that is what we call magnetic flux. To understand it in a deeper way, let me draw this square once again. This is a square, and here are the lines that are passing by. Okay, direction of these lines are upward. We could say that these lines are actually moving in this direction, right? Now, in at a circumstance, what if I consider saying that, or if I say that this specific thing or this specific square is A, that denote us that this is area. Uh-oh. There I could use a thinner version of it. Yes, that will work. So this specific red square is A, the area, and these lines passing by is B. Do you know what does B means? B is actually the symbol which denotes magnetic field. B is the official, or what you could say, and widely used variable for this as a unit or as a symbol, basically, and this is area. Okay. Now, if in a condition, if I say that the A is perpendicular to B, so is that a true condition? Well, if you'll go through the direction of the magnetic field and the area. So are these perpendicular? Yes, it is. Now, what if I say that this is the x-axis, this is the y-axis, and this area actually lie upon the perpendicular situation? Well, I have actually written here something wrong. This will be y and this will be x. This area is actually lying somewhere here, and your lines are passing by according to x-axis. Now, following up this situation, what if I say that B is being a cross product of A? What does it mean by cross product? Cross product actually showcases that thing is in the form of sine theta. That probably means that B is something having magnitude which is with the reference of area that has an angle sine theta. This is the formula of magnetic flux. A little bit surprised? Well, it's nothing to be surprised regarding. We have gone through all the concepts. Now, magnetic flux is shown by phi. This is the symbol of phi. Now, the phi is an official symbol for all the things that are in the form of flux. Now, it can be radiant flux as well. It can be magnetic flux. It can be electric flux. But what makes magnetic flux stand out from these all symbols, like what makes phi different for magnetic flux, is we write a small b with magnetic flux to showcase that this is about magnetic field, since we know that magnetic field is showed by, okay, it got a lot of zoom in. Okay, B showcases the magnetic field, so we have simply written B in with it. Now, if in a condition the A is parallel to B, so what do you think? How many lines will be passing by in that situation? Well, the answer is 0, or either we denote it with minimum. Let's understand it. These are the magnetic lines. They're actually in this situation, moving along with x-axis. This is the area. So how many lines are passing by? Well, the 0 is not directly denoted as 0, since a lot of line can pass in this situation as well, that they can pass by like this. But those are the rarest case, so we do consider saying that this is the minimum situation, where the area is actually perpendicular to the magnetic lines. Now that's in condition. And this is how we actually measure the maximum and the minimum things of the magnetic flux. And this is all for today. Thank you so much for watching. Stay tuned for future videos.